Hello, it is my pleasure to introduce this exciting, fully funded PhD project as part of the Center for Doctoral Training in Autonomous Robotic Systems for Laboratory Experiments funded by the University of York. This PhD project is jointly supervised by Professor Dimitris Kolovos and myself, Simos Gerasimou, and targets the development and evaluation of domain-specific languages that can support the design and execution of collaborative human-robot laboratory experiments. You can find more information by following the URL or the QR code at the bottom right. Robots are increasingly used in several application domains to support labor-intensive and complex tasks, including infrastructure inspection and maintenance or delivery of medical supplies within healthcare facilities. Following the same incentives, robots are being employed also within modern laboratories, working alongside scientists to execute long-running scientific experiments. For instance, the Cougar robot on the right, once programmed and provided with its plan, could operate for up to 21 hours per day. This would potentially give time to scientists to focus more on the most challenging parts of the workflow that cannot be undertaken by a robot. Despite its benefits, designing and executing these workflows and experiments is a complex, time-consuming, and error-prone task. The challenge arises mainly because the sequence of operations underpinning the collaboration between robots and scientists should be explicit and easily understood so that the workflow can be modified as needed. Also, the current approaches of designing ad hoc solutions based on handwritten protocols, spreadsheets, and custom software are difficult to understand, maintain, and share. This project addresses these challenges by leveraging the power of domain-specific languages, which, in conjunction with model-driven engineering principles, help domain experts to specify experiment designs via a specialized and intuitive language. More specifically, DSLs can help scientists to specify the details of an experiment and its workflow, for instance, equipment, procedures, and measurements in a structured and formal way that can be validated, simulated, and executed. Furthermore, through the use of model-driven engineering, DSLs can support experiment design and analysis, such as visualization, optimization, and verification. The overall project objectives include, first of all, to investigate the types of DSLs, graphical, textual, or their combination, that would be most suited for the specification of scientific experiments where human experts and robots collaborate within a laboratory environment. Secondly, to study how DSLs can be integrated with existing experiment design and execution processes to support the automation of experiment workflows. And finally, to assess the effectiveness and efficiency in terms of productivity, reproducibility, maintainability offered by these DSLs when used for scientific experiment design and execution. The overall approach of this PhD follows the normal steps of a PhD at the University of York, and in particular, it has the following steps. Review the literature on DSL engineering and human-robot collaboration. Second, become familiar with the state-of-the-art technologies for DSL development and MDE. Third, conduct interviews and surveys with domain experts, including scientists and laboratory technicians, to gather requirements and feedback regarding the use of DSLs for experiment design and execution. Fourth, design and implement DSLs for scientific experiment design and execution based on the identified requirements. And finally, integrate the DSLs with existing experiment design and execution processes and platforms and evaluate their effectiveness and efficiency through case studies, experiments, and user feedback. You can find more information about this PhD project on the URL and the QR code at the bottom right. Thank you.